Today we're looking at functions. You may have looked at functions a little bit in Year 10. This is covering two sections in the textbook, in Chapter 2 and then in Chapter 5. So this is the first part of functions, where we just look at some of the basic ideas about functions, and then in Chapter 5 we look at all the transformations and more complex components of it. So what we want to do is think, what do we mean by a function? And we start off by looking at a relationship. We've seen lots of times there's a relationship between two variables. And so an example they've taken in the textbook is charges for car parking. So you might go and park your car, say for 2 hours, and then go, all right, how much do I charge? Or how much do I have to pay? So we can see that the longer you park, the more you have to pay. There's a relationship between the time of parking and the charge you're going to be having to pay. If we look at this table here, we see that for 2 hours, you could go, well, I'm only going to pay $9, but then the people at the window could say, no, you have to pay $11. So a table like this is not as accurate as we need to be. So when we're talking mathematically, we want to be precise, we want to be accurate. In the graph here, next to it, we can see that we've set up our graph according to time and the charge in dollars. And the way they've set out the data now is more accurate. So we can see that for when we were doing just 1 hour, up to 1 hour, it's going to be charged $5. So in our graph here, we can see up to 1 hour, the charge is $5. So whether you're there for 1 minute, 50 minutes, 59 minutes, we're going to be charged $5. Some notation you may have come across is this whole circle. If you have a filled in circle, it means that point is included. So that means up to 1 hour, and including 1 hour, we're going to pay $5. The open circle is a point that's not included. So we can see here at the start of the next division, at 1, it's not included. But the moment you go after 1 hour, so if you do 1 hour and 1 second, you are now into the next time frame. So a better way of writing that, and this is actually included in the textbook, is to go 0 for our time. It has to be less than 1 and anything greater than 0. Obviously at 0 you're not going to be charged $5. The next section here is going to be any time greater than 1 but less than and included to 2. So this sort of graph here on the right shows that data with the open circle and the closed circle notation. This is referred to as a piecewise graph, because the graph's made up of lots of pieces. So it's not a continuous graph, but we can certainly see there is a relationship between the time we've spent parking and the charge. There are some other relationships you may have seen, or other ways of describing them. We could just list a set of points, and this is a relationship. And we could plot those points on your Cartesian plane. So I've got 1, 2, 3, 4, 5 points, and that's saying if I have x equal to 0, the y value is 3. If I have 1 for x, the y value is 5. So here are a whole lot of points that we could just wrap up. 0, 3, I'm just doing a rough scale. There's our 3. There's our first point. The next point is 1, 5, so that could be here. The next point is 2, 3. Next point, 3 minus 7, totally out of scale. 3, 5. All right, I'll put a scale on. Minus 7, 5. And there's our 3. So here we've got points. We could show them on the Cartesian plane, or we could just list them. We could also describe a set of points by an equation. which you could draw. And obviously something like that is an infinite line because it keeps going. So you might remember that one, x, y. Hopefully you do. It's a straight line through the origin. And hopefully you remember that the gradient is 3. So this line goes on infinitely, and it's made up of a whole lot of points along that line, an infinite number of points. So another way of describing a set of points. We could also describe them in a mapping, where we set up for the same equation, we can start with our first point, the x is 1, then this rule says it becomes 3. It says 3 times 1. Our next point of 2 we've taken, 3 times 2 is 6. So another way of describing it. The terms you may have come across last year is the domain, or what we call the input. So this is what we put into our relationship. The range is what comes out. So these are terms that you need to be familiar with, domain and range. Domain being the x values you put into an equation. The output or range are the y values that come out. So these are what you call your y values. You could then list those points, but we know if we take this equation that we looked at earlier, then we've got an infinite number of points, so we want to list all those. So these are all relationships. So when is a relation a function? So not all relations are functions. A function is a relation in which every element in the domain has a unique image in the what am I just looking for, a highlighter, a unique image in the range. So when we look at this graph over here, we've got a relation, but does every x only produce one y value? That's the question. And do these have the same x value? They look pretty close. So these 13 points form a relation, but if we're going to say that no two different points have the same x coordinate, then we're going to say that in this situation, we've got these two have the same x value, so this is not a function. It's a relation, but not a function. These 2 points, looks like they have the same x value. They're a bit close. Maybe these ones have the same x value. So this is not a function. So a function describes a mapping from one x to a particular y value. In our first example, for every x, we only get one y value. No matter what x we take, we get one y value. In our second example here, if we take a particular x value, we're getting 2 y values. Another case here, take another x value, we get 2 y values. So this one is not a function. Whereas this one is a function. So for a function, a vertical line will cut the graph at only one point. For a function, there is only one value of the f of x of the function for each x in the domain. So that's the main way we can tell if we have a function. So a function is just a special type of relation. And they're the types of equations we're going to look at mostly in this course. Here's another example. Would you call this a function? No, because you can already see those vertical lines drawn in here. where we get two x values. So no matter where we take here, we're getting two x values for the same y value. So this is not a function as it does not pass the vertical line test. In fact, we can see that any vertical line will cut the graph twice. So let's go back to this type of mapping. In this first example, do you think it's a function? Does each of the x values only produce one y value? Yes. It doesn't matter that two x values make the same y, but each x only has one answer, one y value. Whereas in this example, this x could go to that y or to that y value. So this is like our x's and our y's, or our domain and our range. So 1x, two y values. So it's not a function. Whereas this one is a function. Because each x only gives you one y value. In your calculators, your GDC will only graph functions. You cannot graph a relation on there. You'll have to split it if you want to graph that. So that's the end of part A.